5.6 half angle identities. Alright, so we have double angle identities, now we have half angle identities. So here are our identity formulas, or I mean, that's redundant to say identities, but you can read them, right? Like I've said, I know you're very confident on when to use what. Okay, so let's find the exact value of cosine 15 degrees using half angle identities for cosine. So since we're working with cosine, we need to, the only identity we can use is cosine A over 2 equals plus or minus the square root of 1 plus cosine A over 2. Since we have a cosine in quadrant 1, we know that this is going to be a positive cosine value because we're working in quadrant 1. So what we're actually given is we are given cosine 15 degrees, and that came from here. So in order to get 15, we originally divided by 2. To get the original A, we need to multiply it by 2. So we have 15 degrees times 2 to get 30 degrees. So that's the cosine we're going to be working with, is cosine 30 degrees. Let's plug it in. That's our A. A is 30 degrees. So let's go ahead and do that. We have plus 1 plus cosine 30 over 2. And we know what cosine 30 is. If you look on your unit circle, cosine 30 is square root of 3 over 2. And that's all over 2. Now, this is where things can get a little tricky. If you aren't confident with crazy radicals everywhere, go on my YouTube and just look for radical videos. They're in chapter 7. Like if you look at chapter 7 videos, there'll be a whole bunch of types of radical videos there. They're quick, they're simple to kind of review, but hopefully I can help you with that. So since everything is under the radical, I'm actually going to split this up. So we have the square root of 1 plus square root of 3 over 2, and that's all over the square root of 2. So now I need to rationalize my denominator by multiplying by square root of 2. So we're going to multiply everything by it. So when we do, we have, my bad, square root of, so 1 times square root of 2 is just 2. And then we have square root of 3 times the square root of 2 over 2. But do you notice that this 2 is also under the square root? And it is, so they cancel. Let me bring that out though to show you. So we have square root of 3 over 2. Sorry, square root of 3 over square root of 2 times square root of 2. So that's why they cancel. So we're just left with square root of 3. And that's all over 2. Because it says exact value, we can't use our calculator. Sorry. Alright, let's keep going. Example 2. So we want to find the exact value of tangent 22.5 degrees using any identity. So if we look at our tangent identities, we can use any one that we want. But you want to try and stick with the easier ones, the ones where you don't have to do a lot of work. So I don't really want to mess with the middle one because it has cosines everywhere and there's a square root on top of everything. So I'm going to look to the bottom ones and use one of those because they're just easier to work with. Alright, so the one that we're going to use for our tangent identity is tangent A over 2 equals sine A over 1 plus cosine A. And remember, this is when we halved our value. So we need to multiply that by 2 to get the A we're actually working with. So we have 22.5 degrees times 2, and we have a 45-degree angle that we're now working with. So that's what we're going to be working with as our A, is 45 degrees. All right, so let's go ahead and plug it in. We have sine A, which is 45 degrees, over 1 plus cosine A, which is 45 degrees. Use your unit circle and go ahead and figure out what sine 45 is. So when you use your unit circle, sine 45 is square root of 2 over 2. And that's over 1 plus, so cosine 45 on the unit circle is square root of 2 over 2. And now we just need to simplify. So the first thing I want to do is try and get rid of the denominators because we have a complex fraction. So I'm going to multiply everything by 2. And what that allows us to do is get rid of the crazy denominators in the complex fraction. So we have square root of 2 over 2 plus square root of 2. That's a lot easier to work with. Now, since we have a binomial in the denominator, we need to multiply by the conjugate. So the conjugate is everything that's the same except the sign in the middle. So we multiply by the conjugate. And remember, there's a trick for the denominator. You put a minus in between and you square both. So 2 squared is 4. And square root of 2 squared is 2. And then on top, we still have to distribute. So we have 2 square root of 2 minus 2. Keep simplifying as much as we can. So we have 2 square root of 2 minus 2 over 2. We can take a GCF out. So the top has 2 in common. We can cancel out these 2's right here. So our final answer is square root of 2 minus 1. All right, example 3. Finding function values of s over 2 given information about s. So we're given cosine s equals 2/3, with s being in between 3 pi over 2 and 2 pi. We want to find cosine s over 2, sine s over 2, and tangent s over 2. So we want to find s over 2. We're not given s over 2 in our domain. We're just given s. So in our domain, we have 3 pi over 2 is less than s is less than 2 pi. But we need to figure out what our domain is for s over 2. So we actually need to divide everything by 2. And when we do, we get 3 pi over 4 is less than s over 2, and that's less than pi. And we know that is quadrant 2. So in quadrant 2, since we're trying to find cosine, sine, and tangent, let's go ahead and identify if those are positive or negative. So cosine s over 2 in quadrant 2, that's going to be negative. Sine s over 2 in quadrant 2 is positive. And then tangent s over 2 in quadrant 2 is negative. So I wanted to figure out right away, are my values supposed to be positive or negative, and what quadrant are we working with? And we needed to divide by 2 because we were only given s, but we need s over 2. Now we can go ahead and figure out all of our values. So let's go ahead and start with cosine s over 2. So you look at your cosine formulas, or your identities. You can pick, well, we only have one cosine one. And remember, cosine in quadrant 2 is negative, so we're going to use negative value of cosine. And our identity is 1 plus cosine s over 2. We're given cosine. Let's do it in bright pink. We're given cosine. We're given it as 2/3, so let's go ahead and plug it in. We have negative square root of 1 plus our cosine, which is 2/3, all over 2. Oh, wrong color. Okay. There. All right, so let's go ahead and add our top. So when we add the top, 3 over 3 plus 2 over 3 is 5 over 3. All over 2. And we can keep simplifying because we can divide our complex fraction. And when we do, we get negative square root of 5 over 6. we're going to separate them. So we have negative square root of 5 over square root of 6. Let's rationalize our denominator. And when we finally do, we get cosine s over 2 equals square root of 30 over 6. And it's negative. We can't simplify 30, so we leave it as is. That is our cosine s over 2 value. Now, let's go ahead and find our sine value. So since we only have cosine s, we need to make sure we use a sine identity that only has cosine and nothing else. So we're going to be using the identity of positive. It's positive because sine in quadrant 2 is positive. 1 minus cosine s over 2. We're given cosine s, we know that. So we have 1 minus cosine s, which is 2 over 3, all over 2. Let's simplify our fraction, because we can. On the top, we have 3 over 3 minus 2 over 3, which is 1 over 3, all over 2. We simplify inside, so we have 1/3 divided by 2, which is just 1/6. We separate our fraction, so we have square root of 1 over square root of 6. We rationalize our denominator, and we get square root of 6 over 6, and that is what sine s over 2 is. Last but not least, we can finally find tangent. So we can use a tangent identity, but why? Because we know that tangent s over 2 is the same thing as sine s over 2 over cosine s over 2. And we actually have those values. We have our sine s over 2, and we have our cosine s over 2. So let's go ahead and just plug them in. Remember what I said in the last video, if you have sine and cosine, you can find tangent. So we have sine s over 2, which is square root of 6 over 6. We have cosine s over 2, which is negative square root of 30 over 6. Our denominators cancel. So we have square root of 6 over negative square root of 30. Let's keep simplifying, because we can, well, there's a couple things that we can do. You see how they're both under radicals? We can actually simplify these fractions right now. Since they both have a radical, we can simplify this into square root of 1 over the negative square root of 5. Because 6 and 30, they have 6 in common, so we take it out. Now let's simplify. We're going to rationalize our denominator. And when we do, we finally get negative square root of 5 over 5. And that actually works because tangent was supposed to be negative, and it is indeed negative. Alright, last example, thankfully. So, just like most of our last examples in this chapter, we have the opposite side now. So we're given the right side, we need the left side. So if we look at our identity, let's try and match it to one of our identities. So you can go ahead and look at your identities, and you'll see that it matches cosine a over 2 equals plus or minus the square root of 1 plus cosine a over 2. So this is the side we're given. We're given the right side. So we need to go to this side, the left one. All we need to identify is the a. And we have it, it's 12x. So let's plug it in. We have cosine, excuse me, 12x over 2. So we get cosine 6x. And that's it. So let's do the same thing with b. So for b, that matches a tangent identity. Tangent a over 2 equals 1 minus cosine a over sine a. So all we need to identify again is the a. And we have it. It's 5a. So let's go ahead and plug it into a. So we have tangent 5a over 2. And we can't simplify that, so we leave it as is.